All right, 2018 BC number 6. Okay, so we have a Maclaurin series given for natural log of 1 plus x, and we're asked to, in part A, write the first 4 non-zero terms in the general term for f of x, which is defined as x times the natural log of the quantity 1 plus x over 3. So the very first thing that I'm going to do is, do you see how the x has been replaced with an x over 3? I'm literally going to replace all of my x's with x over 3's. So instead of having x minus, I'm going to have x over 3 minus, instead of x squared over 2, it's going to be x over 3 squared over 2. And then plus x over 3 cubed over 3 minus x over 3 to the 4th over 4. Those are 1, 2, 3, 4 non-zero terms. And then the general term would be negative 1 to the n plus 1. And I'm literally just going to replace the x with x over 3 in this one too, to the n over n. Okay, I didn't write f of x equals, I didn't write f of x is similar to, so I don't need necessarily a plus dot 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 at the end because of the notation that I had used. If I had written an f equals here, then I would have needed a plus dot 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 at the end. Okay. It is my recommendation to you that you leave it like this in part A. Okay, that you do not simplify this any further because you will get full credit for this in part A. And if you accidentally make a mistake simplifying it, you won't get penalized for it. Okay, in part B, when it asks you to find the interval of convergence, I'm going to have to ratio test this thing. So it would be in my best interest to simplify this now. So I'm going to now say, okay, I have x over 3 plus x squared over 2 times 3 squared plus x cubed. Oh, I'm sorry, I had a minus back here and I made it a plus. Plus x cubed over 3 times 3 cubed minus x to the 4th over 4 times 3 to the 4th. And then my general term is negative 1 to the n plus 1, x to the n on top, and n times 3 to the n on bottom. I put an equal sign in the beginning, so I need a plus dot 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 at the end now. And again, like had I not put that here, I wouldn't need this at the end necessarily. Okay, so now I have a general term, which I'm going to take with me so I can ratio test this. So I just carried over my general term. My general term is just the negative 1 to the n plus 1, x to the n over n times 3 to the n part. And for part B, I'm going to ratio test this. So I'm going to take my limit as n approaches infinity of the absolute value of the ratio of 2 consecutive terms. So I'm going to have negative 1 to the n plus 2 times x to the n plus 1 over n plus 1 times 3 to the n plus 1 divided by the original or multiplied by its reciprocal. So multiply by n times 3 to the n over negative 1 to the n plus 1 times x to the n. You know, first of all, I have absolute value bars around this thing. So regardless of what the exponents are, all this negative 1 stuff is just completely insignificant because of the absolute value bars. You can just completely ignore it. Okay, now I'm going to look for the stuff that doesn't need the limit. So my x to the n plus 1 divided by x to the n, that's going to leave me with an absolute value of x. Right, I have an extra x up top than I do on bottom. So I'm going to have absolute value of x. And then my 3 to the n's, I have an extra 3 on bottom. So I'm going to pull out an extra 3 on bottom. Right, 3 to the n divided by 3 to the n plus 1 is 1/3. So I can pull out the stuff that doesn't need the limit. Okay, the x stays inside absolute value. And then I'm going to multiply that by the limit of what's next. So I'm going to have times the limit as n approaches infinity of not what's next, but what's left, which would be n over n plus 1. And this limit is actually, if I look at key term over key term, I'm going to have this limit approach 1. And so I end up with just the absolute value of x over 3. Okay, now because I just ratio tested this, in order for my ratio test to prove convergence, I need my ratio to be less than 1. Means the absolute value of x has to be less than 3, which means x has to be between -3 and 3. Okay, at this point, I'm going to be checking endpoints because it does ask for the interval of convergence. Okay, so if I plug in x equals -3 into my series, and here's where I want to look at the general term. Okay, and the general term, I just kind of disappeared. It's if I plug in -3, my general term is -1 to the n plus 1 times -3 to the n over n times 3 to the n. Okay, the question is, how do I simplify this so I recognize it? Well, I'm going to divide out these two pieces. And if I divide out those two pieces, I have -1 to the n plus 1. Now, -3 to the n divided by 3 to the n is -3 over 3 to the n, which is -1 to the n over n. Okay, and now what you have to do is, because this, I know this looks like an alternating series, but it might not be an alternating series. If you try plugging in n equals 1, I'm going to get -1 squared times -1 to the first, which is a positive times a negative, which is negative. If I plug in n equals 2, I get -1 cubed times -1 squared, which is a negative times a positive, which is negative. If I plug in n equals 3, I get -1 to the fourth times -1 cubed, which is a positive times a negative, which is negative. So this is actually equivalent to having a -1 over n. Okay. Now, if I threw a sigma in front of this, because this is the general term of a p-series, right? And if I want to, instead of having this notation, I can go for the sum of this. I could put sigmas in front. Now I should recognize that this is a divergent p-series with p equal to 1. All I have to say is that it's a divergent p-series. Okay. And then I'm also going to plug in, so then I'm now divergent at x equals -3. I'm also going to check the convergence or divergence at x equals +3. If I throw a +3 in, I have the sum of -1 to the n plus 1 times 3 to the n over n times 3 to the n. Now this is a clean break. These divide out, and I end up with -1 to the n plus 1 over n. Okay, now if I try plugging in if I don't recognize this to be absolutely an alternating series, I can plug in different values of n again and see that it does alternate between positive, negative, positive, negative. So as far as alternating series test goes, you do not need to show AP your work for this. If you need to do the work, then do the work. But alternating series tests that the series must decrease an absolute value to 0, and the non-alternating part of this is 1 over n, and that will certainly have a limit of 0, and it will be decreasing as the denominator increases. And so this is a convergent alternating series, which is all you need to write for AP on this. And therefore, the interval of convergence is going to go from -3 exclusive, I don't include -3, to +3 inclusive. Okay, and that is my interval of convergence. I've shown the work that led to my answer. I don't need to show anything else here. C asks about everybody's favorite thing, which is error. Okay, so alternating series error is asking to find an upper bound on p sub 4 of 2 minus f of 2. So again, I want you guys to recognize that this means error. And when you see error, I want you to state right away that error is less than or equal to the absolute value of the first neglected term. Okay, now I'm going to have to look a little bit back to the beginning. So I have this series right here was my simplified version of it, and it asked me to use p sub 4. So p sub 4 would be, I shouldn't have boxed this part. Well, it's not going to let me erase easily, but p sub 4 is the first 4 terms, not necessarily the first 4 terms, but it's the terms up through x to the 4th. Okay, so p sub 4 are the terms up to x to the 4th. So I'm going to recopy this on this other slide. right here. Okay, x over 3 minus x squared over 2 times 3 squared plus x cubed over 3 times 3 cubed minus x to the 4th over 4 times 3 to the 4th. I took that from part A. All right, now we want to know what the error would be. So the first neglected term on this, what would the next term be? Well, the next term would have been an x to the 5th, okay, over a 5 times 3 to the 5th. Now what's changing here is that my x's have been replaced with 2's. So I'm going to be less than or equal to the absolute value of 2 to the 5th over 5 times 3 to the 5th. Okay, and that is the upper bound. I don't need to say any more. This is my justification. Okay, I don't need to simplify this. Normally they ask me to show that it's less than a certain number. They didn't ask me to compare it to anything. So that's it. I use the alternating series error bound, which is strictly the first neglected term. And I figured out what the first term we left off with, which is with an exponent of 5. Because we ended with an exponent of 4, so the first neglected term had an exponent of 5. And there we go.